My name is Enoch Tom, and I'm here with my colleague. Yeah, so we'll take you through the presentation. Yeah. Our project title is Optimization of Sustainable Sisal Fiber-Based Composite Filler for Car Body Scratch Repair in Malawi. So our motivation is that car body fillers are usually imported from countries like South Africa. So this means that they are actually costly and also less accessible to small-scale users. And also there is no local production of these high-quality car body fillers. And also on the same point, there is no standard optimal curing methods. So that means that there is actually a need to develop a sustainable, cost-effective, and a durable car body filler in Malawi, hence enhancing the local industrialization in Malawi, which is one of the pillars of Malawi 2063 vision. So our problem statement is we actually have two parts. We have the problem and the proposed solution. So automotive industry actually faces challenges in creating a car body filler due to limited availability of environmental resources and also other things. If you are to look at conventional car body fillers, we have grass fiber and we have metal fillers. These ones, of course, they have a better performance, but they also have their setbacks. They are costly, they are imported, and also these ones they require actually proper treatment methods and also proper handling techniques. If we are to look at unenforced polyester, this one is also actually it is the commonly used, which you can see. This one, it is the commonly used. It is more accessible, but it also have its setback. It has poor thermostability, weak interfacial adhesion. It will also have poor mechanical properties. So after considering this problem, we realize that there is at least need to be a solution. This challenge needs to be solved. So our proposed solution is to develop a sisal hemp fiber based composite filler by enhancing its mechanical properties, the thermostability, we have the adhesion. So as such, if you are to do all these things, it will enhance its performance, and also at the same time it will be less costly. So we are moving on. Each and every project, it has its objective. So the first objective is to prepare the composite filler from the locally available sisal hemp plant, and then after that we are to mix the sisal hemp fillers with the resins. Then following that is to conduct an experiment to carry out various tests about the same process, like curing methods, treatment techniques. And then finally we are going to validate our results by the data of product from the industry and also from the literature view. So continuing with that, we can see that here is a list of our methodology. You can zoom in to see properly. It's actually a list of our methodology. This part are our inputs, and these are our output. So if I'm to just explain a single point, of course the list is a load. For example, on testing and evaluation, so we have a lot of tests that we are going to carry out, but actually we carried out only two tests. We carried out hardness testing and impact testing. Those other tests were not carried out because of our other challenges, which my colleague here will mention about it. So this is our methodology, and reaching this far, I would like my colleague, who is an expert to the rest of the part, to take you through.
Thank you so much. As said, my name is Chikunje Tsopiri. I'll take you through the sample preparation and the results themselves. So basically, we can just have a glimpse at the table here. As my colleague said, we did hardness tests and impact tests. So these were the samples prepared for hardness tests, others at different curing temperatures. So here, what we are basically doing, we have a problem that in the car industry, car body repair industry, is that when these body fillers, the polyester fillers, are applied on the car bodies, they tend to crack within 2 to 3 months. So we are trying to combat this issue. This is because of the heating of the body of the car. This causes the metal of the body of the car to expand, causing the sisal filler to crack. So we have there's a solution on that where the industry uses glass fiber to reinforce that. But glass fiber is a synthetic fiber. Here's the glass fiber before it was prepared. Then we decided to use a natural fiber, which is sisal fiber, to replace the glass fiber. Here's the sisal fiber. We crushed it in 2 small particles for easy mixing with the body filler to reinforce it to prevent it from cracking. So here are our samples that we prepared for the testing. For hardness testing, here are the samples at different curing temperatures to see the variation in the results. So it was basically not only about adding the sisal hemp, but it was also to find the best curing treatment and temperature. So we put some other samples, like at the 27, we put it in the shade curing it at room temperature. Here it was cured under UV lighting, and here it was cured under the oven, which was at 70 degrees Celsius. So here is the layout of our experiments. We did hardness, we did impact testing. Here are the samples after impact testing. Then our results were as follows. You can bring the camera up to the results. It showed that the glass fiber is the one with the blue line. Here is the hardness results versus the curing temperatures. So the results for hardness for glass fiber were higher than all the other results. Sisal fiber, however, was competitive with the glass fiber. From 27 to 70, all of them were rising. But above 70, the non-reinforced composites were going lower, as we can see here, without any fiber, which is showing that under hardness testing, the body fillers are prevented from indentation. If we add fibers, they will prevent from dents coming on them. Under impact testing, we also have the sisal fiber performing the best. This was to measure the toughness of the sisal fiber. And the non-reinforced was also performing competitive, but because of overheating at 70 above, the microstructure degraded. So without reinforcement, it shows that the polyester resin degrades above 70 degrees Celsius. But we can see the glass fiber reinforced was a bit lower at the impact testing, because the tensile strength, as you can see down here, the tensile strength of the glass fiber is a bit lower than the sisal fiber, which is a bit tougher. So sisal fiber exhibited the most toughness at the impact testing, with the non-reinforced composite with the poorest results. So what are we saying here? We are saying that glass fiber has been proven in terms of toughness to retain the strength we wanted to retain in preventing the cracks on the car body fillers when they are applied within 2 to 3 months. So what are our recommendations for this project? Our recommendations are that we should conduct now the environmental aging tests. Since glass fiber is a natural fiber, we know that it degrades over time. So we need to conduct environmental aging tests to see for how long can it last. Then we can also expand the mechanical testing matrix to include tensile, flexural and fatigue testing, to include all the other tests, the chemical testing as well. And lastly, we can investigate a hybrid mixture to say what is a new intervention of making our experiment to grow. We can add a bit of sisal ratio and glass fiber ratio to see the best hybrid mixture. So as we have reached this far, our limits in this project were time and resources. But however, this project shows promising results for the sisal hemp fiber to to be used in the car body repair industry. Thank you very much. The required elements, we require to do more investigations first by doing more tests, and we, as I said in the recommendations, we have to create a hybrid reinforcement to see different mixtures of sisal and glass fiber where we can produce the best ratios for different kind of uses, because these composite fillers are used for different applications, not only the car body fillers. So to scale it up, we need to find out and discover those hybrids, which one performs the best.
So far, our target marketing, there is cheetah motors, and also there is
let me answer it. Is the airline industry, the car industry, the boats. We can go to the shipping industry as well, because it's all about repairing the metal body parts of the mechanical components.